5 tech companies now spend more building data centers than the entire world invests in producing oil and natural gas. That money is starting to reach the grid you pay for every month. That comparison comes from the International Energy Agency. The figure crossed $400 billion in 2025. The IEA expects another 75% on top of it this year. Demand moved with the money. Electricity used by data centers grew 17% last year, and the AI focused slice of it grew 50. The IEA doesn't have to take anyone's word for this. It tracks these sites by satellite, and its imagery shows AI specific data centers tripling in capacity over 18 months. You might already be pushing back because the numbers you've seen about AI look tiny. Google measured its own system and published the result. The median Gemini text prompt uses 0.24 watt hours. In simpler words, that's 9 seconds of television. So if one prompt costs almost nothing, why are 5 companies spending money on this scale for buildings to serve them? The answer sits inside Google's own paper in a breakdown that almost nobody covered. I'll show it to you in a minute. This buildout runs on the same grid you do. Lawrence Berkeley National Laboratory put US data centers at 4.4% of the country's electricity in 2023, and it projects somewhere between 6.7 and 12% by 2028. That range is wide because nobody knows the ceiling yet. When demand this size lands in a few counties at once, it forces new power plants and new transmission. Then comes the fight over who pays for both. The IEA is careful on this point. Rising demand doesn't automatically raise prices, but loads this large and this fast can stretch a grid to the point where it does. So, what is a data center? Once you strip the mystique, a warehouse full of computers with a life support system attached. Here's where the electricity goes. Servers take about 60%, storage takes about 5, networking gear takes up to 5 more. Cooling takes anywhere from 7% in an efficient hyperscale site to over 30 in an older enterprise one. AI uses these buildings in 2 modes. Training is the famous one. It's the process that builds a model before anyone gets to use it. It runs the hardware at full load continuously, sometimes for weeks. Then comes inference, the industry word for answering you, and that side scales with every new user. Inference is the opposite shape. It rises and falls with the people asking, and it keeps growing as long as signups do. The IEA counts active users tripling and revenue growing 5 times over in the past year. Every one of those conversations lands in a building like this. Now, the breakdown I promised. When Google measured that 0.24 watt hour prompt, it also published where the energy goes. The AI chips, the accelerators every headline is about, account for 58%. The rest is everything around them. Host processors and the memory that feeds them take up another 25%. Idle backup machines take 10. Cooling and power conversion take the last 8. The chip that gets all the headlines is barely half of the machine. That is the answer to the title question. Why does AI need data centers? Well, the chip cannot run without a building engineered to keep it fed and cooled, and that building draws power even while the chip does nothing. While we're inside Google's paper, there's a detail almost every headline got wrong. You've probably seen Google's 0.24 watt hours compared against OpenAI's number. Sam Altman wrote in a blog post that the average ChatGPT query uses 0.34 watt hours, and outlet after outlet ran the two side by side like a scoreboard. I read Google's technical paper and Altman's post next to each other, and the comparison collapses in the fine print. Google's figure is a median. OpenAI's is an average. Quick reminder on average and median. An average adds up every query's cost and divides by the count, so a handful of monster queries can drag the number upward. A median is the middle query, half used more, half used less, and the extremes barely move it. Those are different statistics measured across different users, asking different questions, and neither company has published the distribution behind its number. I think we learned something real about each system and almost nothing about which one is more efficient. Anyone who scored that matchup for you skipped the methodology. The IEA's base case has global data center electricity use roughly doubling from 485 terawatt hours in 2025 to about 950 by 2030. Translated, around 3% of all electricity used on Earth, with the AI focused share tripling inside it. Geography sharpens the picture further. The United States alone accounted for 45% of global data center consumption in 2024. Where does that power come from? The chase for it is reshaping the energy industry in real time. Data centers now sit behind roughly 40% of all corporate renewable power agreements signed in 2025, per the IEA. The pipeline of conditional deals between data center operators and small modular nuclear projects grew from 25 gigawatts at the end of 2024 to 45 today. Conditional is the load bearing word there. These are options on reactors that mostly do not exist yet. In the US, developers tired of waiting years for grid connections are building their own gas plants on site, and the IEA's satellite work shows many of those stuck in early stages too. Money turned out to be the easy part. Amazon told investors it plans roughly $200 billion in capital spending this year, and CNBC puts combined guidance for the four biggest spenders near $700 billion as of their latest earnings calls. Guidance kept rising all year, so treat those as floors. Meanwhile, supply chains are tightening across the exact equipment the buildout needs, from gas turbines and transformers to advanced chips themselves. That finding is the IEA's. Grid queues and permitting are stretching planning systems in every major market. A board can approve $200 billion in an afternoon. Nobody can build a transformer factory that fast. Now hold two facts at once. Energy per AI task is falling by at least a factor of 10 every year, and the IEA says nothing in the history of energy has improved that fast. Total demand is rising anyway. Both are true, and the second is happening because of the first, not despite it. My read: efficiency does not slow this build out, it funds it. Every time a prompt gets 10 times cheaper, someone finds 10 new uses for it. Energy hungry uses like AI agents keep showing up exactly as per task costs collapse. One more piece of honesty about the numbers. Xiaolei Ren, an engineering professor at UC Riverside, argues Google's per prompt figures leave out real costs, including the water consumed by the power plants feeding these sites. Google stands by its method and calls it the most complete view of AI's footprint available. Ren's critique is on the record, and so is Google's defense of its method. And there's a second gap worth knowing. Google published the cost per prompt. It has never published how many prompts it serves. Multiply a precise number by an unknown, and you still have an unknown. The one figure that would settle AI's true footprint stays private. So, why does AI need data centers? Because the chip is barely half the machine, and the machine is only part of the story. The rest is transmission lines, cooling loops, backup generators, water, and a grid that was never designed for customers this size. For a century, the biggest bets in energy went into pulling fuel out of the ground. As of last year, 5 companies are betting more on buildings that answer questions. Whether that bet pays off will decide far more than their stock prices. It is already deciding what shows up on your power bill.